Okay, let's do a little final review here for Trig Pre-Calc. So on number 1 here, I'm trying to figure out, oh, that must just mean the cosine of negative 180 degrees. So there should really be a parentheses there. But remember, you're allowed to use a unit circle, right? But if I was to do a quick sketch, I know that negative 180 means I go in a clockwise direction 180 degrees. And so I'm going to be right here. And remember that cosine corresponds with x. So this value right here on the unit circle, remember, is negative 1, 0, right? So therefore, what's the cosine of negative 180? Has got to be negative 1. Now, you should be able to use a unit circle for this, right? But that's how I would have done it. So hopefully that helps. Here we go. Number 2. Now, this is one on the identity. So remember, the most common identity you should know is sine squared plus cosine squared equal to 1. And see, I can make a cosecant squared if I divide 1 here by sine squared, right? So if I divide everything by sine squared, I just made another identity that you should be familiar with. Sine squared over sine squared is 1, plus cosine over sine squared is cotangent squared. Remember, cotangent is cosine over sine, equals to cosecant squared. And so what is cosecant squared if I minus this 1? Is cotangent squared. But I do want to remind you that you should know that sine squared plus cosine squared equals 1. And as we just found out, cotangent squared plus 1 equals cosecant squared. And if I divide by cosine squared here, the third identity you should be familiar with is sine over cosine is tangent squared plus cosine over sine is 1 squared equal to secant squared. So these 3 you should be pretty familiar with. I don't know if you're given that or you're allowed to put that on your cheat sheet, but that's something to think about, is you ought to add some of these identities like that. All right, so number 3 here. Now, guys, so remember that we started here and we're just rotating a full circle and then another half a circle and a little bit more. The reference angle is always directly back to the x-axis. You go directly back to the x-axis here. And so the reference angle is this right here. So this is where I'm a little stumped, because normally we would have to still start here. So that would be 180. Okay, so let's figure out what that reference angle is. Sorry. So if I take 590 and I take away 360, that's the first full circle here. Okay, that's one circle right there, one rotation, right? What is that? That's 230 degrees. So then I do another half a circle, as I was saying. That's another 180. So that's 50 degrees left. So I know that the reference angle here is 50 degrees. Had a little brain fart there, but basically the angle back to x here is an amount of 50 degrees, right? So again, if you do a full circle, that's 180. If you do another half a circle with that, I'm here now, 360, right, is a full circle. Then I did another half circle, 180. Notice I'm already up to 540 degrees. So what is 590? It's 50 more. You always reference back to x. Okay, on number 4, notice the right triangle there. Notice they gave us the angle. We're supposed to solve the triangle. So the first thing I would do is, let's find this side over here. I'm going to call it x. Notice that it's opposite, and the 4, look carefully, is my hypotenuse. See, the right angle's up here, and the hypotenuse is always opposite the right angle. So this is my adjacent side, but we're going to find that using Pythagorean theorem. So we should know that if we're doing opposite with hypotenuse, according to some old hippie caught another hippie tripping over apples, right? Opposite hypotenuse is sine. So we know that the sine of 25 degrees has to equal the opposite, which I'm calling x here, over the hypotenuse, which is 4. So x, therefore, if you do the algebra, I'm going to times both sides by 4, and I'm going to get x equal to this. So notice that when I do the sine of 25 here, it's 0.4226, and then I'm going to times it by 4. So this is the missing side. You're probably going to want at least 2 decimal places, 1.69. So I know that this missing side here is 1.69. Now, what about this missing side? Well, let's reorganize here a little bit. So here's our triangle, here's our right angle. We just figured out this is 1.69, we know this is 4, we know this is 25 degrees. Let's find this missing side, but we should be able to use Pythagorean theorem. So let's call this side y, since I called this side x. I know that y squared plus 1.69 squared equals 4 squared. So y squared is going to be 4 squared minus the 1.69 squared, right? I'm going to square this, minus it from that, and then I'm going to be able to solve for y. So notice that when I do 4 squared minus 1.69 squared, that's 13 and some change. When I take the square root, it's 3.625. So maybe you round this off to 3.63. Okay. So going back to our problem here, we now know that this side is 3.63. So we know all the sides, and you could see already the answer is D, right? We figured this out to be 1.69, which rounds off to 1.7, and this missing side is 3.6 rounded off. And the 65, remember, a triangle always adds up to 180. So if I took 180 minus the 90, that's 90, minus the 25, that gives me the 65. All right, one more. This is another reference angle one. So notice we're going around almost a full circle. So a full circle is 360 degrees, right? If we only go 345, let's take that away. That's 15 degrees difference. That means this angle in here, the reference angle, is 15 degrees. So hopefully these 5 problems make sense. Again, oh, there's one more thing I want to show you real quick. If you're using a scientific or graphing calculator like this, make sure it's in degrees mode. That right there says degrees. So make sure you go in the mode and change that to degrees. If you're using a regular calculator, you may want to make sure it's reset so it's automatically in degrees. But here's the test. If you do sine of 30 degrees, which is the same thing as pi over 6, you should get 0.5. If the sine of 30 is not 0.5 or 1/2, you know it's in radian and not degree mode. So you probably want your calculator in degree mode so you can do all the calculations that we just did. So I hope this first video helps you. Come by and ask me questions in the morning if you still are stuck. All right? Talk to you later.